Here I've got a football being kicked at a 40-degree angle, and the initial velocity is 24 meters per second, and we want to know what the range of the kick is. Now the word range in projectile language means dx. How far does the football travel through the air before it hits the ground? So we know it's going to follow this parabolic arc and land somewhere over here. And we're trying to figure out what that dx actually is. So once again, we'll set it up into those two directions. We've got our horizontal direction. And for that, we only need three variables: dx, which is what we're looking for, vx, and time. And vertically, we need all our variables: v initial y, v final y, ay, t, and dy. Now let's start figuring out some of these values. Now anytime you've got an initial velocity that's at an angle, you have to break it down into its horizontal and vertical components. So the vertical piece, since this side is opposite to the angle, will be 24 sine 40. So this is v initial in the y. 24 sine 40 gives us 15.4 meters per second. Similarly, if I want to find Vx, and remember the x velocity never changes, it's constant throughout the path, Vx will be cos, will be 24 cos 40, which gives us 18.3 meters per second. Now, because this is a type 2 projectile, there's some symmetry involved. Its final velocity will be exactly the same as its initial velocity, except down. Same angle, same everything. So all we have to use for information from that is that your final velocity in the y will be negative 15.4 meters per second. Also, it lands at the same level from which it started. So my overall vertical displacement is 0. Acceleration in the y is negative 9.8. And we've got a lot of information there to proceed. Now, the only way we can find dx is if we know time. We can't do it in the x column yet, so let's focus on the y column. So let's utilize this fact that dy is 0 and see if we can solve for t. So let's pick an equation without v final in it maybe. Maybe we decided we're not comfortable with that assumption. Let's use this one. dy is VOT plus 1/2 AT squared. Now dy is 0. My v initial was 15.4. We're looking for time. 1/2 negative 9.8 t squared. Simplifying it a little bit, I'm going to take all of this over to the right by adding a 1/2 9.8 t squared to both sides. So that becomes 1/2 9.8 t squared is equal to 15.4 t. Now if I divide both sides by t, one of the t's cancels. And we're almost done. Now 1/2 of 9.8 is 4.9. So I get 4.9 t is 15.4. So to solve for t, it's just 15.4 divided by 4.9, which is 3.14 seconds. That goes over here in my x column. And the only thing left is to solve for dx. And since there's only one equation, it's easy. dx is vx times time. Vx is 18.3. My time is 3.14. And 8.3 times 3.14 is 57.8 meters.